I just landed in Calgary a month ago, so I'm pretty new in the city, and I have to say I'm loving Calgary. So this is something really, really nice, especially for my kids. And yes, so right now I work, across those years, I've been working with a lot of different technologies, but right now my main languages are Ruby and Microsoft Azure, but I have to say that I love Java. Actually, I have a Java tattoo in my leg, so yeah, I really love Java. But yeah, that's why the examples I did here. So I don't have time for a live code because the presentation is a little bit big, but I will share with you the GitHub with this presentation after this meetup. Yeah, I don't know what I did because I have it. So nice. But before talking about CQRS, I would like to talk about monolithic architecture in order to explain the different type of architecture and why do we actually need CQRS in our environment. So basically, monolithic architecture refers to a traditional software design where all components and functionalities are integrated. So it means that we don't have like different services to do different operations. So we have just one big box, and inside this big box, we are deploying like UI and everything together. So basically, this is like a diagram for a monolithic architecture. In this example, we have like product management logic, we have authentication logic and user interface. Everything inside one big, let's say, box. And this big box is actually connecting to the database. In some cases, this is really bad, but I still think that this is a really let's say, spot for monolithic applications in the market, especially when we're talking about MVPs. So MVP is like minimal valuable product. And one of the benefits about monolithic architecture is because it's really easy to create, it's really easy to deploy. So we don't need like a fancy architecture, like, I don't know, like we don't need to spend a huge amount of money like Microsoft Azure or Google Cloud Platform, or even at AWS, to deploy a monolithic architecture. So it's easy to debug. So when you have a problem, and we know that we'll have when you deploy software to production, it's really easy to track it because, you just need to put some breakpoints and that's it. We don't need to handle different services, right? But of course, we have drawbacks. And the first drawback, that basically is the main reason to go to another architecture type. It's called, it's the scalability. It means that, let's say that we are receiving a huge amount of traffic in our monolithic application. How can we scale that? It's really hard because we cannot, the only way that we can scale that, we can add more memories, we can like do a vertical scaling. So basically it's really hard to use monolithic architectures for like heavy load applications. And yes, of course, another thing that we commonly see in the market is that monolithic applications, they will turn into legacy applications because it's really hard when you have like a big application where you have everything together. It's really hard to upgrade. So that's why we see a lot of companies still using Java 8 because it's really hard to basically upgrade that. Now that we know what is a monolithic architecture, let's talk about microservices architecture. So basically, microservice architecture, we have the same idea about like segregate stuff. And then when we are talking about, when we're using the last example, basically, let's convert the monolithic application that we have into a microservice architecture. And then instead of having everything together in one big box, now we have three different services. We have the product management service, we have the authentication service, and we have the user interface. So it means that now we have three different small applications. And in order to have the full feature, they will integrate between them. And in order to explain how they will integrate between them, I'm going to do a logical flow here. And of course, they have their own database, so it means that we can easily segregate the data context as well. So it's a really nice approach when we are talking about domain-driven design and something like this. So let's follow the logical flow. So let's say that I have a user, and this user wants to log into a website. So basically, the UI will send an HTTP request to the authentication service in order to validate the credentials. And then since this is like a synchronous operation, the authentication service will accept or deny this request. In our case, it will accept. And basically it will return and say that, okay, your login credentials, your login and password, the credentials are okay. Now, here is your authentication token. Nice. So knowing that, the user now will go to a dashboard or something like this in our application, in our UI. So the user wants to navigate to the product page in order to see all products that we are offering. And then the user interface will send HTTP request, so it is a GET request for the product services. So this is the first interaction of product services so far. And then it will send the authentication token. The product service, in order to validate this token, will communicate with authentication service and say, okay, I received a request, here's my token, is it valid? So if it is valid, the authentication service will validate the token, and then after that, the user, the product management service will return to the UI request with the requested product. So yes, we can see some benefits about doing that. One of the benefits is scalability, so we can scale them separately. So let's say that I'm getting like a half load in, I don't know, in the product side, I can scale the product side, or let's say that I have like more microservices connect to the authentication services, so I can put more instances to the authentication service to, serve every microservice here. So this is a really nice approach to scale our microservices applications. Another thing is like flexibility in technology, because when I have something like this, I can create, for example, my authentication services using Java or other technology, and I can create my product manager services, for example, using another technology, I don't know, Ruby or something like this. Yes, we also have other benefits like independent deployment. So let's say that I have a bug in my product, I don't know, some feature inside my product service. I don't need to deploy everything. I just need to deploy my product management services, fixing the bug, and that's it. So it's kind of, it gives us more, let's say, productivity when we are like faster reaction to the situations in our daily basis, like deploying a feature or things like this. So the agility is also another nice thing. Drawbacks. When we're talking about microservice architecture, the first thing is like complexity. Because before, we had just one application and everything was there. So integration with database, everything was there. User interface, but now, no. Now we have 3 different services, and we have to communicate between those services, create a communication between those services, and we also have to handle and manage those services. So let's say that we are talking about, we are going to deploy this microservice architecture in AWS, for example, and we want to use like Kubernetes or, some container management to handle the life cycle of these services and apps. So we must have like, let's say, a robust architecture to serve our purpose, meaning that it's not that simple to just deploy, for example, a fat jar to any kind of cloud and it will work. So we have to handle these kind of communications, VNets, and security, and it's kind of more complicated. And of course, the testing scenario is also something that's it's hard. Sometimes it's hard because, for example, let's say that we had just unit tests for our monolithic application. Now we must have different type of tests, like integration tests, contract testings. So it gives us more complexity. So it's always a trade-off. If I have like a benefit, definitely I will have a drawback in our architecture. Yes, of course, monitoring is, again, another problem, because now instead of monitoring just one application, now I have to monitor 3 different applications. So meaning that I have to have also distributed monitoring, because we are now doing a lot of requests between the services. So if you want to track a request from the beginning, we must have something called like a distributed tracing. So yeah, so definitely it's more complex to handle microservice architecture than a monolithic architecture. Nice. Now that we understand what is a microservice, let's talk about EDA. That's like event-driven architecture. When we are talking about event-driven architecture, basically we are talking about to replace some operations, of course not all of them, but some operations to asynchronous operation. So basically, EDA is really powerful. It's a really powerful design pattern in software architecture that help us in scalability, flexibility, and responsiveness by decoupling our components. Because if we go back here, for example, I'm saying that the product management service knows the authentication service, right? So there is like a coupling between them. But now, when I'm talking about EDA, the idea is to remove these, like, it's to decouple those services, and it's really nice because it gives us also more fault tolerance when we are talking about our services. And here is another service, another example to talk about EDA. So basically, in this case here, I have like a shipping service, an order service, a payment service, a notification service, and a message broker, and a database. So as you can see, we should not use like event-driven architecture for something that's really simple. So I want to release an MVP, something that, I have to prove my concept. Probably if you go to use this, you are going to lose your time to market, right? So you're going to try to find like the perfect architecture, and someone probably will release the product before you. So you must use event-driven architecture only when you have a problem. So trying to not over-engineering your architecture. So in order to explain that, how it works, I will use the logical flow again. So let's say that I have a user, and this user wants to buy something in our e-commerce or platform. So okay, the order service, when the user click to buy the product, the order service here will send an event to our message broker that can be can be a RabbitMQ, a Kafka, depends on your architecture, and saying that okay, order placed. It's really important to mention that when we are talking about events, we should talk about past actions, right? So it means that I will not send an event say place an order or something like this. So it's all about some command that was already executed by the service. So now I'm sending the event say order placed event to the message broker, and then this is the beauty of EDA. Now the order service basically doesn't know who will take that, because it's not his responsibility to understand, the next step of the flow, right? So we have another component called the payment service. The payment service has interest in the order place event. So it will consume this event, saying that, okay, I got an event from order place, I want to respond to this event. And then it will take the payment services, like consume this order place event, and then the payment service will process the payment. I don't know if you go to call like a process payment gateway or like PayPal, something like this. After that, the payment services will publish another event saying that payment confirmed. Can be like payment denied as well, but for this example, I'm going to use the payment confirmed. And then, again, the payment services doesn't know who will answer this event, so who will consume this event. And then let's say that I have a guy called shipping service, but the shipping service really wants to consume the payment confirmed event, because the responsibility of the shipping services is actually prepare the shipping of your product that you just bought, right? And then the shipping services will consume the payment confirmed event, will process the dispatch of the order item, but in parallel. So that's another thing that's really nice about EDA. So at the same time that I have like services, like an application consuming an event, I can also have another application consuming the same event in parallel, right? So I'm not blocking at all the user. So the flow is like a smooth flow. And then the other service will pick up this event, and then we'll update the order status saying that payment confirmed or something like this. Another guy that is really interested in this payment confirmed is the notification service. So the notification service will consume this event in parallel. So now we have three different services consuming the same event in order to do three different operations. So the notification service will consume this event and will send a notification to the user, like an email or SMS, I don't know, saying that, okay, your payment status is like confirmed or denied, something like this. Nice. And then, I mean, after the payment, the shipping service execute process the dispatch of this item, it will publish an event saying that shipment dispatched. So now it means that our order was dispatched. And who is interested in this guy here? Basically, we have another service. It's called the order service again. So the order service will consume this event in order to update the order status. So the order status before was payment confirmed. Now the order status is like item dispatched or something like this. But in parallel, our notification service will also consume this event and send a notification to the user saying that, okay, I got your payment. We already sent the notification payment. Now I'm sending to you the dispatch notification saying that, okay, your product will arrive, I don't know, in 10 days or something like this. And this is really nice because we're talking about like a big flow here. If we wanted to do this like in a synchronous way, let's say that it will block the end user having like a huge loading in his UI, saying that, okay, waiting everything, so I don't know, 10 minutes to process an item. So it's like unacceptable when we're talking about user experience, right? So that's why this is a really nice stuff. And because it's really resilient. So let's say that my notification service is down. So this is not a crucial service to process the payment. So if I have my notification service is down, I still can process orders. So it means that right now I have like a resilient architecture. Yes, so again, we have the same benefit about microservices, like the scalability. So let's say that I have like other components, other services that they are communicating with the payment services. So I can increase the number of instances for the payment service. So it means that I can scale the payment services without touching in order services or shipment services. So nice. Of course, we have drawbacks again. And the biggest drawback about an EDA is something called data consistency. So since we're talking about asynchronous event, it's really hard to ensure that every database will be synced, right? Because we have this event, the data consistency problem right now. And that's really important that we have mentioned when we are developing services in an EDA architecture. We must create our services with like hypothesis strategy. So what is an hypothesis strategy? It means that if my payment services, for example, receive this order placed even twice, I will not charge the user twice because I know already that this event here was already processed. So this is really important to have in mind when we are developing our services in an EDA architecture. And of course, the learning curve, it's complicated. Because we're talking about this is like a simple example, of course, but we can have like, when you're talking about fintech's world, it can be huge. We can have like hundreds, of microservices here communicating between them. And for example, we can have a cluster of message brokers. So right now, I only have one message broker. But if we're going to perform like a really heavy operation, we can like increase we can scale our message broking, have a cluster of message broker, or we can have like a cluster of RabbitMQ, for example. Yes, now that we kind of understand what is like an event-driven architecture, let's talk about CQRS. That's like a really simple concept in software architecture. And basically, CQRS, or Common Query Responsibility Segregation, is a pattern in software architecture that separates the responsibility of commands and queries. The main idea inside CQRS is to have, I mean, of course, we are not going to use CQRS when we are like talking about monolithic applications, right? So when we have like a huge amount of requests that can block our user operation, we must use CQRS, because here, in this example, we are splitting. Let's say that we have a service called comments. And for example, let's talk about Instagram. So Instagram uses a lot CQRS. And let's talk about the comment. So we have a post, like a photo from, I don't know, Neymar. And then we'll have like a lot of people posting comments in this photo. And we're going to have a lot of people reading these comments. So we cannot block them to add comments, and we cannot block them to read the comments, right? And that's why I'm going to use this example here because I think it's simple to understand. Let's say that I have my REST client. So let's talk about, like, this is my React application, for example. And then I'm going to separate commands. That basically commands is like a post, put, patch, and delete operation, like an action, to the get, to the get request, that it is a read operation. So again, I'm going to use the logic flow to explain that. So basically, let's say that I have a user who wants to add a comment in one post. So basically, the REST client will send a post request to the command service. So the command service handler will get this HTTP request, will perform the request, meaning that it will create the comment, and then it will publish an event to the messaging broker, saying that, okay, I just did one operation, and this operation was comment create event. Now, in order to sync my database, the query service will consume this event here and will perform the same operation in his database. So it means that it will sync both databases here. The beauty about that is because we can have different databases. So it means that, for example, here's the benefits, of course, but I want to do this. So let's say that I wanted to have a really robust database for like write operations. So I can have, for example, Cassandra here, and on this side, I can have an Elasticsearch. So because it's like an optimized database for like queries. And I can have like the beauty of the two worlds in one single architecture. Again, can we use with the same database? Yes, we can, and then we don't need this event stuff. So for example, if you want to use a Postgres here, we can use the simple main replica replication, and then we don't need to send an event and consume the event. But when we are talking about CQRS, I mean, normally we are applying a CQRS in an event sourcing strategy. I don't want to talk about event sourcing here because I mean it's a really complex scenario, but I mean hopefully next time I can talk about this. But we should have in mind that we should not perform in this kind of architecture. We should not do this if you don't have the problem. So again, let's not over-engineering our architecture. So because we're going to spend a huge amount of money here. So again, I'm splitting one service into two services. So it means that now I'm paying more money for my cloud provider to have like the same thing, right? So we should only do this when we really need to do this, right? When actually it hurts, and that's why I would like to talk about monolithic applications first, because I like the idea to not over-engineering. I mean our let's say our work, right? Okay, so yes, again, the main drawback about this is to sync the database. So again, if we're talking about, let's say, a hospital system that like every millisecond will interfere, count, we should not use this because this can create like eventual consistency. So it means that, let's say that I created the data here, and maybe it will take like some milliseconds to update my Elasticsearch database. So if I really want, like, if every millisecond counts in our I don't know product, we should rethinking about it. And yes, so questions? It's just a joke, please. If you have any difficult questions and I don't know the answer, I promise that I will try to find an answer to you. So, yeah.
In the CQRS model, what does the message broker actually do?
The message broker will be responsible to get the event. To get the event that it was performed. So in this example here, I'm talking about created event. So the message broker would be the, let's say, the resilient approach to ensure that our query database will be in sync with our right database. Again, we don't need a message broker in this case. Normally we use Kafka here because like it's a distributed stream platform. But again, if you have Postgres and Postgres in both sides, you can use a replica strategy. So you don't need to have a message broker. But if you want to really use like the full power of CQRS, we should have different database here. So again, one optimized in write strategy and one optimized in query strategy.
Thank you.
Welcome.
What is the recommended way for authentication?
Sorry, can you? Authentication. So basically, in this case here, I'm not handling authentication. So we are talking about authentication between the services in general, right? In this case specifically, you can, before process your post request, you can validate your token, right? Saying that, let's say that the recipient here will send a token for you, and then we'll have the authentication service, and we following the same idea that we did in the microservice strategy. And then before process the action, you should go to the authentication service and then perform the, let's say, validation of the credentials. But again, this is up to your architecture. So let's say that you have, I don't know, you have these services here inside a really secure VNet that can only be accessed by, I don't know, a guy that it is inside this VNet. It's up to you to decide which kind of authentication factor you're going to use. Or you can also use like a single sign-on. So if you have, for example, Keycloak, that's really famous, you can do the same. So your authentication service here, in this case, will be the Keycloak. So yeah, it's kind of up to you to decide which kind of strategy about security you're going to use. You can use like tons of the like client certificate pinning. So there's a lot of like strategy for security that you can apply in this API here. Okay.
Yeah, thank you for the presentation. This is very interesting for me because I'm trying to do something similar. I have a high volume of IoT streams coming in, and I can either serve them quickly or I can either write them quickly. I did think of a distributed design like this, where I would have two databases. One would be a Postgres database and for writing, and the other one would be a file format.
Okay.
A compressed file format, such as Parquet.
Parquet, yeah.
Right. For now, I'm not going ahead with design because I came across certain limitations that you've mentioned already. Eventual consistency. The other thing being synchronization. So I feel like this is a perfect opportunity for me to get to know if you've implemented this design in your company, what challenges did you face related to synchronization?
Yes, so basically, I worked in a huge Brazilian bank. It's called PagSeguro, and we implemented that. But all of this was not enough for our case. We also had to implement something called Saga pattern in order to fix this eventual consistency stuff. Basically, the Saga pattern here, in this case, will play the role to ensure that our basically database will be sync, and if something happens wrongly, we can easily roll back the chain of events. So again, we had the same issue because we're not talking about money, so it's really complicated to have like event consistency. So we use Saga pattern to handle this. I can send to you like an example about Saga pattern. So, but I mean, it's not difficult. We have two ways to implement Saga pattern. One is called choreography way, and another is called orchestration. So basically, they have the same idea in order to create a chain of events and easily roll back the events if something happens. So it will ensure that the database will be synced, but it will not ensure that the database will be synced immediately, right? So we still have like some seconds about delay or milliseconds. And in this case, for example, in your case, you have to create a data pipeline here. You have to create something called, the ETL in order to transform your data to like a Parquet. So because you are going to get like plain texts, from your Postgres, and then you have to run like a data pipeline, Apache-NiFi, or I use it a lot Apache-NiFi. I really like Apache-NiFi, but you can use like data flow or something like this in order to perform your ETL, and then ensure that your databases will be in sync. But yeah.
I decided to drop the idea of using CQRS pattern. I didn't know it had a name. The reason being, as I already mentioned, so what I went ahead for now is to use streaming service as a mid design plug and play model where I can implement streaming service. For now, I'm just using the Amazon Synthesis Firewall. It's easy for me to get started. Just aggregate all the incoming streams of data and dump it into object storage into the S3 bucket. But because it's Parquet, it's hard for me to write or update the data. So I decided to use a table format on top of all my Parquet files.
Okay.
There's three table formats, mainly the delta, iceberg, and so they kind of build an abstraction on top of those files, and you can use those Parquet files as a database.
Okay, nice.
So let's talk about
yeah, definitely. There are a lot of ways to implement CQRS, and I think this is the beauty of software architecture, right? Nothing is written in stone, so you can just get an idea about one architecture design and then see your need and then implement the CQRS in a way that will benefit you, like specifically. And but that's why I love like software architecture.
I would also come back to you later on.
Definitely, my pleasure. Yeah, definitely, my pleasure. And thanks. More questions?
Hello. First of all, CQRS seems to be a little dependent on message broker. So whenever the message broker is going down, you can see the program failure. So how can actually minimize that? When you actually get the message broken down, you can actually synchronize automatic sources and all kinds of stuff. That's if the links can be fast with the processes. How can you actually do that and be sure that all the stuff in the process?
Nice. This is a really nice question. And when we have a situation like this is not a problem only for CQRS, this is a problem also for EBA. The main idea here is to have a cluster of message brokers. So not have like just one single instance about RabbitMQ, because if these instances go down, Sorry. But if you have a cluster of RabbitMQs, I don't know, running 3, 4 instances, if one go down, another one will take the place. And for example, for Kafka, we have something called Zookeeper. And the Zookeeper will play this role to ensure that we always have an instance in our cluster that will be responsible to say that, okay, I'm alive, okay, so you can send events right here. So yeah, really nice code. Or you can just use like a manager service. I don't know, PubSub, Azure PubSub, or like Kinesis or something like this, the best Kinesis. And then you're kind of sure that it would not go down because this is a manager service for your cloud provider. So you're kind of safe in this side. But if you don't want to create a vendor lock-in, meaning that I don't want to use, let's say, the manager service about my cloud, so I want to have the flexibility to change cloud providers whenever I want, yeah, you should create the cluster and manage the cluster by your own. So this is like a strategy to not, to not have a problem in your message broker in this case.
Questions? Thanks so much for the nice presentation.
Thank you.
So I might have a different set of questions. I didn't think CQRS is one of the projects, or it was a great CQRS order. But what a microservice application can we never use different databases.
Okay.
A single database was lacking. So coming back to your word of over-engineering, would you say that it is actually over-engineering? Or is it completely fine that if you are using microservice architecture, still use database for the separation of concerns?
Yeah, you can have it, but you're not using the full power of microservices, right? Because let's say that you have a problem in your database, both services will stop working. So you have a single point of failure in your case. If you really want to segregate, let's say create like a bounded context following DDD, you must have two different databases because now we can say that they are decoupled. So they are not coupled anymore. Because in this case, using the same database, I already saw that in the companies that I worked for. Yeah, you have a single point of failure. So, it's kind of complicated to say that, okay, it's not a microservice. It is a microservice, but you have a point here because if your database goes down, you have like high coupled services.
So that means if you are using CQRS, the better strategy is to only use it in a distributed environment.
Definitely, yeah, definitely.
Okay, thank you.
More questions?
More questions?
Online questions? Nope. Online questions? Nope. I think that's it. So thank you very much, guys. Really appreciate. Again, sorry about the beginning of the the meetup. We had some issues with microphone. And yes, let me see. Yeah, and that's it. Thank you. I was waiting for it.